I don't think we're too far off, but it's definitely who's paying for the storage of the data, who's, as with anything, who's leading that effort and who's in charge. And I
Yeah.
think depending on what state you're in, it's the use case that'll drive who may want to do that. So it's more of, with anything, I think we can do it. It's not outside the realm of what we can do. It's more of who's in charge and who's paying for it.
Welcome back. The podcast today is a continuation of the series that we've been doing now with regard to introducing you to really inspiring young people who are in the engineering profession. They're what I call the 21st century engineers who are working on projects that will actually move into 22nd century. And their experiences, their opportunities are things that I want to share with those that listen to this podcast because I think they're inspirational. As somebody who's been in academia for over 40 years, I look at these individuals as success stories and individuals who are achieving great things and will continue to achieve great things throughout their career. Today, we're being, I'm going to say, blessed, Sarah, by the presence of Sarah McEwen. I've known Sarah for more years than she's going to admit, and more years than I can do in my head. My calculator's sitting here, but I could pull it up, but that's okay. She was impressive as an undergraduate student, and she has been continued to be impressive in my eyes and in my inspection, and to others as she's moved through her career in various capacities. I knew her as an undergraduate student. I've known her through her work with the American Society of Civil Engineers. And so, with that, I'm going to kind of jump into this. Sarah, thank you for taking the time to be with us today.
Of course, happy to do it. Happy to talk about anything that could help future engineers as they make their decision and navigate their career paths.
And I truly do appreciate it, as do the listeners. So let's get started. The question that gets asked a lot of people, myself included, multiple points in my career, but I'm going to take the positive spin on it, and that is, why did you decide to become a civil engineer?
So I've had to give this kind of speech quite a few times because my family is pretty interesting. My dad is a mechanical engineer. My mom is a computer engineer. My uncle was a natural resource conservation engineer. I have cousins that are electrical and chemical engineering. I married a civil engineer that I met at Mississippi State University, and I became a civil engineer a lot of because of that background. Our family was very much, you're either going to be in the medical field, be a teacher, calculus teacher, math teacher specifically, or an engineer. So growing up with two engineering parents that worked in research, that worked on some different space flight hardware, I always knew that I kind of resisted it at first. I really wanted to look into law and all the other fields I thought would be important, but ultimately one work study session while I was in high school, we had a work study program. I worked with the material engineering lab at UAB, and it was just fun and interesting and problem solving. So I kind of finally succumbed to the fact that my parents had nurtured me into an engineer, and I just needed to pursue it. So that, in conjunction with the Mississippi State Engineering program over the summer that was for seniors at the time, that kind of just solidified that I would go study engineering at Mississippi State. But by that point, I kind of knew there was no choice. It was engineering or nothing. It was ingrained in me.
You weren't able to break down the will of your folks. As you may remember, Kelly, my youngest, was at the department for a little while. And actually, if it wasn't for physics, she probably would have finished her doctorate in engineering as opposed to geology here recently. But engineering, dad pushing engineering on my youngest, Kelly, got to the point where engineering became a four-letter word. And so I had to relent and let her find her own way. But I'm sure the way that you found resonates with what you're doing, and allowed you to do what you're doing, that you did get the degree, and that you're moving forward with it. You're doing great things. One of the questions that oftentimes get asked of academicians, particularly those that do interviews with prospective students, is does the program prepare you, or are you coming at with a conventional undergraduate degree in civil engineering? What did you feel prepared for? Or is it really something that you are doing or wanted to do? And what was it that the program missed that you've had to make up on your own?
I think, and working with the advisory board, it's something that I think is very much aware of, but something that I think we're missing right now is the transition into the software platforms that a lot of companies are using. We are teaching the give and find solutions, the problem solving, the mathematic basis, the understanding of how all of our equations that we use to simplify our analysis are built and derived. And I think that's incredibly important. But I'm very interested in how technical electives could allow students to really focus and have a leg up on competition when it comes to software use and application. Thinking Bentley, MicroStation, CAD, go ahead and be exposed to open roads while you're in school. And then from the hydraulic side, more advanced HEC-RAS, SRH2D, PC Swim, like some of these softwares. That way your day one on the job is at, a more productive level than maybe some of your competitors at other schools. So just thinking about how Mississippi State could really advance that. But beyond that, I think the foundation was always really broad, and I thought that was really important because we work in such a cross-discipline driven field that while I love water resources and that's what I really love to do, I need to have the fundamental understanding of all of the disciplines so I can be the best partner to my coworkers. So that way I can really understand their language and how they interpret things. Because you do work together. No one, very rarely do you have a project that you're in a vacuum on where you don't touch anything else. Especially as it relates to the new funding that's been released, we're having more and more cross-discipline work. I know we were chatting about ARPA earlier today, but ARPA, really came down in Mississippi, and it was a big funding source. So you're having more civil site development, you're having more analysis for stormwater projects, but a lot of times those projects intersect with the wastewater projects. So you have to coordinate. So in my mind, the broadness was really important. Having touched a little bit of everything in the discipline was a great preparation. And then the way the professors attacked homework to make sure you were doing the give and find solution. I think it's more important than getting the right answer is, are you troubleshooting? Are you working through it, defining what data is available to get to that next point of how do we solve the problem? Because that's day in and day out the work that we do.
Well, you've hit on a number of points, so let me try and drag you back, drag the conversation back to a couple of these. With regard to IT, and you've got to put in perspective. I agreed with everything you said. I mean, in exclamation parts, high font, bold. In terms of the technology, having that breadth and understanding the fundamentals of how the technology works is integral, and that's important. But certainly, giving individuals a chance to work on and use, and maybe to some degree master, or at least come to close to mastering the tools that are used is important. Completely agree. I remember, I've been in this game long enough. I remember when we didn't have options, we had to build our own tools, and then the tools came along. Right, for example, the STAD and RISA and other packages that came around for structural analysis in the early 90s, and people said, "Oh, we won't need civil engineers anymore because we'll just put the data into the computer and it'll come," which of course is fantasy. And if anything, we've embraced that idea of computer aided design and drawing and all the rest in that. And as you've mentioned, some of these packages have add-ons that allow you to do different things. In the water resources area, for example, I can design a water treatment system, not a water treatment, excuse me, a water distribution system, a wastewater collection system. I can analyze dam breaks. I can look at subsurface flows, and all in that water resource arena. There's a lot of packages there, but knowing how to use them effectively, optimizing them, is the question. So with that out there, there's a lot of conversation about artificial intelligence as, and I see that as a potential interface, the next phase, where for optimization and what have you, it would be up to the engineer to apply an AI system, uh, some form of machine learning that would come in and run those programs for us to help us come up with better, more optimized solutions. Is that something that you see on the horizon? Do you see that as an opportunity or an impediment?
I, a couple of examples come into play. There's a lot of tedious things when it gets into some of the watershed hydrology interpretations to really develop what your flow is. So, I think the optimization is going to come into, we have massive amounts of data, and we can become more automated and proficient and use AI to process that data, whether it's LiDAR, whether it's looking at land use and developing like land use change, what the NLCD does, whether it's applying the NLCD to a curve number and cross-checking it with the soil group to kind of go into your TR55 SCS method. So there's a lot of things I think we can do that will be more proficient and the better use of the funding to do through those processes. And then the engineer comes behind and checks everything and gut checks it and make sure that it's giving you the not only correct data from what's there, but where was the problem in the initial data that maybe gave you the weird output. So I think there's going to be a lot of low hanging fruit from the start. And then beyond that, I think it's going to make us be more proficient in running different scenarios to evaluate risk. So we see it in coastal analysis where you have these hundreds of suites of storms that would have taken, ungodly amounts of time to process. Well, now you can run them much quicker, and you can use the cloud storage, and you can really we'll be able to do more iterations rather than just saying, here's the 10-year, 24-hour storm. We can say, we've run our entire suite of storms, and here's where your critical point lies. So that's what I see it as, is it's going to give us where we can offer more to our communities and more to our clients from a risk perspective as we get rid of like the tedious nature of some of what we're doing, at least in my field.
Yeah, absolutely agree. And on both ends of that spectrum, running for a particular 100-year event, and again, for those that should be acutely aware, that simply means it's a 1% probability, and it's based on data that is now antiquated. So already we're beginning to talk about having to run a 500-year event just to actually address what a 100-year event is. But then you also on the low scale, and what you're doing is you're running extremes, assuming this is actually the worst case. What if I have a 100-year event with a high storm, a high flood surge, or high winds? So you have to. It's not descriptive enough. It's an old attempt to try and be conservative at a time when we can be much more realistic, less guessing. And on the low flow side, same thing. Maybe October low flow is Q107 is the issue, but maybe not. Maybe there's another situation because of changes in reactor process or temperature or flows or inputs that maybe it's just better to do a full scenario. It's almost like running a digital twin, which was going to be the next thing I was going to ask you about, because you covered three of my other questions in answering the first. Imagine that. Somehow you always seem to do that. But have you seen or have you experienced, or is there a conversation going on in your ecosystem about digital twins and how they might apply to projects?
I don't think I'm familiar with that term.
Oh, okay.
Lynn.
That it's basically a living computer model that takes real data and constantly updates as a way of telling you how things are working today, not how they might work. But it's a modeling management tool that allows you to identify issues. So,
Yes,
so yeah,
there's been a lot of discussion, I think, on these watershed scale models that
yeah,
could be live, like you forecasted, kind of like how the rivers and tributary system is very much live forecasted and run continuously,
right,
but that on more of a watershed rainfall scale. And of course, with anything, data is going to be your biggest asset and limitation. So, fully modeling and assessing all stormwater infrastructure, especially in urban areas, really collecting times of concentration, like all of the things to get your initial model going would be a limiting factor in my mind. But I definitely see a place where you're either you've spatially varied the ellipsoid of your rainfall based on a variety of intensities. Then once one happens or you predict a certain amount, you can say here's all the possible risk for flooding, and that can inform emergency management. I don't think we're too far off, but it's definitely who's paying for the storage of the data, who's, as with anything, who's leading that effort and who's in charge. And I
yeah,
think depending on what state you're in, it's the use case that'll drive who may want to do that. So it's more of, with anything, I think we can do it. It's not outside the realm of what we can do. It's more of who's in charge and who's paying for it.
right. Well, the storage is certainly part of it. The data sensors is certainly part of it. It's one thing to develop a digital twin for, let's say, a water distribution system where you're already highly metered, highly
Contained.
the telemetry's in place, and you can take old data. You can even just work it off of the design estimates, but you're taking real time data in a real time sense and constantly updating coefficients and the model relationships in a real time way. Uh, yes, having designed or developed a water quality model for 200 miles of waterway, um, yeah, a different animal. Yeah, and being able to now collect that data real time in both depth and breadth would certainly allow a much more robust analysis as to what's going on, and again, predictive. We see this. We see a dam drop in the in the diurnal oxygen concentration. Well, we know we got a problem. How do we address it early on? Or we see a change in the stochastic flows. Well, how does that do it? And of course, you tie all this into to rainfall and whatever else. So this is not something that's being taught. It is something that's coming down the road. So then the question becomes, uh, and I just came from a meeting where a lot of engineers got together and talked about things like continuing professional competency. And so, how do you see this playing into that question? Do you feel competent enough right now with what's happening to practice for the next 30, 40 years of your life? Or do you see yourself having to constantly uh, develop, expand, replace, augment the knowledge that you have and the expertise you have through continued learning?
I think as a certified floodplain manager, because of and using like NFIP regulations and because of all the new tools that FEMA comes out with, it's one great example of, even though I've been a CFM for many years, I still need to reread the regulations and reread how the new tools were developed to be the best, certified professional to provide advice on anything that's asked of me, whether it's base flood elevations. So that's just one small subset. But even that, like even though I've been doing it for years, I don't always feel entirely confident without knowing how everything has been changing. So I don't see there's going to be ever a point where I'm not learning something new or trying to understand, what went into the development of a new resource or tool or guidance document. That's why we have tech briefs. That's why we have continuing education and conferences, is because people are always learning things and having new experiences. And it's important to listen to those lived experiences and case studies to make sure it doesn't apply to you and there's not something better you can be doing.
Yeah, and for those that are listening that know me, uh, one of the other connective pieces with you and me is our relationship in the American Society of Civil Engineers, and that involvement with, in our case, the Institute, Environmental and Water Resources Institute, EWRI, and attending their conferences and both presenting and listening to and engaging in the not just the conference work, but the committee work, which you've also been involved with, so that it's not just consumption, it's really steering the direction and having input on what they're doing, which you've done remarkably and worked really well. I've heard nothing but praises for the work that you've done in that capacity. Let me run to that service piece for just a second, because I know that, as I said, you've been really involved with ASCE. Uh, was it very difficult for you to get engaged with ASCE and have input and share thoughts and vision?
I think it just, it depends on what level and what part of um, the groups within ASC you want to be a part of. I would say I started out at a company that was very supportive of being involved in the branch and the section. So it was very easy to become a younger member representative on the local, chapter. And then a lot of times that rolls into a state section. And then when you get to the state section level, you start to meet other people from other states. And then you might go to a region level. So you kind of have the sections, branches, and more people leadership parts of things. And then you have the technical component. And I would say for me, the technical component was way more intimidating because I'm not in academia and it is more university heavy at times. But at no point does anybody discount the lived experiences of designers versus the more experimental part. It's just finding your place and contributing to the conversation in a way that's helpful overall. And, really listening to the people at the more institute level, and what all they have to say on like more of the theoretical side at times.
Well, that's a great point. Well, again, I would submit that you're a competent enough, secure enough professional that carrying your own weight in an environment where you may have been in the minority uh, probably wasn't as big a problem as it might be for some. But again, that confidence, as I've often said, if you become a subject area expert, it isn't about the degree; it's about the knowledge and the expertise. And so, knowing that you have that skill set as you do, and bringing that into the environment because you have, and realizing that you're a valuable part of the conversation, which you are, uh, there's nothing to take away just because you don't have three PhDs and look like Albert Einstein. Thank God, just really works. And I applaud you for stepping in and doing that. And I also would add that having people know you, and I mean know you, not by name, not by face, but really know who you are, what you're about, engaging people at these meetings. You just never know who it is that's going to all of a sudden become president and say, I got to put her on a committee. And so, it's just kind of the way things unfold. So engage, network, building that platform. Um, I I also know and I really want to spend some time sharing with the audience about the work that you've done with the Mississippi River Model. I think it's a quite interesting project, having spent 40 years here in Mississippi. It's a project that it's an item, an activity that I think is going to have long-term benefit. And I'd kind of like to just, because there are a lot of people don't understand what this model is about or why it exists, or why it's important to save it. Could you thumbnail that for us, please?
Yes. So the Mississippi Basin Model is what the engineers would call it. We kind of added the river onto it to make it more locally understood about what's out there. But there's a physical 60 acres of concrete model that represents the Mississippi River Basin, and it kind of goes from the Gulf of Mexico. It's physical rendering from the Gulf of Mexico all the way up to Sioux Falls. And it has all the rivers and tributaries. It kind of covers major confluence points, and it's accurate to the 1940s quad maps, 1 to 2,000 horizontal, 1 to 100 vertical. We tell people if the Rocky Mountains were out there, they'd be 50 feet tall. There's a Discovery Channel episode on Hidden Americas that was recently released, I guess last September. So it's just a physical model that was built as a reaction to the 1927 flood, 1928, Congress passed the Flood Control Act that gave authority and funding to the Army Corps to do research and development into maintaining and operating the Mississippi River. So General Eugene Raybould wanted to build a physical model that could run different simulations, historical events to see what's happening on the Mississippi River. So they kind of had been doing physical modeling, but they hadn't done anything on this scale. So this is the largest scale physical model in the world. And it looked at, had 70 inflow controllers and really modeled 79 main simulations to complete its mission. And then after it completed those simulations, the Memphis district leased it and ran some different things around Memphis. But I would say the most important simulations that kind of came from this model that we have reports on include the Birds Point, New Madrid floodway. In '93 they brought it out of retirement and ran simulations focused on operating the Birds Point, New Madrid floodway. And as a result of those '93 simulations, in 2011, when they made the decision to operate the floodway, they pointed back to the simulations to give them confidence in what would happen hydrologically and hydraulically if they operated it, and would it do what it was intended and hopefully led to do, which was kind of save parts of Memphis and further downstream from significant loss. So that's one of the most important recent, unintended long-term things from that model. But a lot of what was done on this physical model really informed the computer modeling that resulted in the HEC-2, now HEC-RAS, HEC-RAS, and soon to be like HEC 2025 programs.
Mm-hmm. Yeah, and so I was talking earlier about digital twins. This is a physical twin. In back in the 20s and 30s, this was the best way. I mean, the mathematics hadn't caught up. We were really struggling with the mathematics and how it applied. And of course, they have evolved over the decades, over the century since. But there was a problem, and that was loss of life, loss of property in substantial quantities. And this was a reasonable approach. The idea of being able to observe physically and deduce what was happening, and more importantly, what changes needed to be made to prevent further loss of life in the event of another flood. Well, really important model in the history of engineering, but how important is it? Why is it so important to you? Why do you bother with this thing? I mean, it's out in the middle of nowhere, north of someplace. I'm trying to get my bearings. I lost my compass.
It's right on
Somewhere
the
west
border
of Jackson. Yeah.
Clinton and Jackson. So
Yeah.
it's in the city of Jackson, but right on the edge of Jackson. And to me, it's one of those marvels of engineering. It's so like as a hydraulic engineer, it's such a tangible, physical thing I can touch and see and connect with engineers of the past on. And every single panel was hand sculpted, so it's kind of art in a way.
And how big's the panel? I know the answer, but yeah.
They're 10 by 10 foot panels, but they're 68 concrete.
Made out of concrete.
Yes.
Yeah. Can you imagine sculpting 10 by 10 feet, not 10 inches, 10 feet by 10 feet of concrete sculpted to represent the topography in scale, hydrologically in scale. Wow. Okay. Keep going. Sorry.
But it's just, when you get out there, you're amazed by what you see, but then you start to think through like, man, what impact could this have had on just like visitors, but like for me, it's like the kids in the area. I've worked with some different JPS schools. Our local women's transportation seminar chapter does a lot with Stewpot, and you just connect with kids that didn't grow up with engineering parents. And so you just wonder, like, if I had access to this kind of like a children's museum type thing, and you could explore it and learn about the water cycle, you could learn about economics up and down the river, you could explore the delta. There's so many things you could do because it's a giant map to really connect to kids on geographic literacy, but also water resources and how the river is the life of the U.S. So I just think of it from that perspective. It's such a cool thing to not have the community be able to interact with on a daily basis. Like, why are we not doing it? What's stopping us from really making it what it could be from a visitor perspective and just a learning opportunity.
Yeah. Well, and I know you've gone out of your way, as have the others in the group that's trying to restore and preserve the model, have had and hosted and fostered activities at the model to try and raise consciousness, to expose people in the area about it. And as somebody who grew up next to a French and Indian fort as a kid, who rode to it maybe once a year on his bike and never really appreciated the significance of that structure, you're taking the time to open this up and show it to the individuals, just how important it was, how instrumental it was in really what we're even doing today. The establishment of the Waterways Experiment Station, now Engineering Research and Development Center of the Corps of Engineers, the establishment of the modeling concepts that ultimately got replaced by mathematical modeling. And there's even arguments about the validity of some of the math models versus the physical models. So I'm not getting into digital audio versus analog audio, but it's kind of the same kind of argument, that touchy feely piece. That's great. I think you should be applauded for doing it, and I do applaud you by bringing it up as part of our conversation today. Let me take one last tack with you, if you don't mind. I want to go back into your work environment, what you're doing. I know you live, but I know that you've recently made a career change, that you mentioned earlier, working for a company. It was a fairly large organization, international organization. I have former students that work for them around the world, literally, won't mention the name. But recently you decided to switch over into a different role, slightly different role, elevated role, with a more regional engineering organization, not a one-man shop or a one-woman shop, but a fairly substantial firm, but certainly not the global reach that the other company had. Any particular reason? Was it family? Was it food source? Was it opportunity? Was it the color of the logo? The what? If you don't mind sharing, what motivated you to make the change?
Well, I would say, even coming out of school, you're interviewing with companies. I thought I was going to go work with one company that I co-opted with all through
Mhm.
college, and then when it came time to sign the offer letter, they kind of changed what the environment was going to be. I was going to have to be at a plant site, and that, as a right out of college, wasn't exactly what I wanted to do. It wasn't in the location I wanted to be in, because I was,
Mhm.
engaged at the time to my now husband. But I think the biggest decision on where I've worked has always come down to, where is my family at? What location is it in? What, obviously, pay is a role, but it's not the role. It's more of what benefits, what culture, what environment am I in, and does that align to my family and goals and where I'm at. So coming out of school, where I worked, it was really a great environment for young engineers. I was in a lot of different disciplines. I got a good overview from everything, but then I was given a new opportunity to take a larger step when I went to my second company. Um, and that they trusted me to fill a role that maybe a lot of people on paper wouldn't have given to me. So then when I made that jump to the international company, it was the best thing for our family and opportunity at that time. And then I was there for a really long time. I was there for 6 years, and I loved it. And everybody I worked with was phenomenal. And it was, like you said, it was international. So it was a lot of connections to people around the world that wrote the documents, that led the guidance on that. And that's a very important experience to have. But being in a very large company also means there's a lot of, things that go along with that, because they have to be in charge of 50,000 people and make sure it's very uniform. They have standards and codes and procedures that everyone has to follow because they are of that size and magnitude. So when my new opportunity came, with my current firm, it was just it wasn't that I was looking for anything. It was more of just an opportunity that I needed to look at because it was very interesting. So my husband and I sat down and we talked about it, and we are like, does this align to where we're at with our family? And one of the things to me that stood out was, not only was it just really great people that I've always appreciated knowing in the engineering community locally, um, and a great chance to get to work with them, but it was also the fact that they serve so many communities locally. like such smaller communities, whereas my international firm was more of the DOT, more mega projects. It wasn't as much the local connection with the places down the street. So it was an opportunity to kind of come back and serve more directly with my fellow citizens in my state, and that was kind of intriguing to me as well. So it wasn't what, like I said, it wasn't like I was looking for anything at the time to make the change, but it felt like this was a different type of challenge that after talking it over with our family, it seemed like a good fit for what we were hoping to do.
Well, the term that I've somewhat recently embraced while people talk about work, excuse me, work-life balance, it's really work-life infusion. It's the integration of one's work and life values, all of which are reflected in what you do. And so, what I'm hearing you say is, first off, is that you saw a way of being more impactful in your community by making this change. And it worked better for everybody that you feel in some way responsible for in that family, community, what have you, profession. And so it was a good time for a good change. And it wasn't that you were moving away from anything, it was that you were moving towards something.
Yeah,
And
something just slightly different and new. And I think it working for an employee owned company is different than working for a publicly traded company. So that to me has been the biggest unintended benefit, was because, I now work for an employee owned company. It feels more like you're more locally supported. You're not having to ask for resources. It's more already in place because it's just a different financial business model.
that's right. Yeah. And the other piece too, you mentioned in passing, was that when you're dealing with a mega corporation, there's a certain tendency to want everybody to be a little more cookie cutter, whereas in your current situation, you could maintain a little higher level of individualism, and so express yourself, do the things a little more that you want to do. Still have to get the job done. The job scope may have changed a little bit, but it hasn't really changed that much. Just how, whether it's this or that or the other thing, it's just the size maybe, or the dollar amount maybe, but at the end of the day, it's a challenge, and you're solving problems, and you're impacting lives, and you're making the world better. And after all, what do engineers do but impact lives and make the world better if we do our job the right way? Well, that's great, Sarah. I I could talk to you for another half hour just on that subject, but I don't have a half an hour. So I guess we're going to have to kind of wrap things up. As you and I, kind of in prepping for this conversation, had talked and touched on a lot of different things, and there were a lot of things that we just didn't touch on. So I guess to wrap things up, the question I'm going to put back in you, and turn this over to you in a way, by basically saying, is there anything you'd like to share with those who are listening to the podcast today that you think will be impactful or important for them to understand, whether it be the idea that you can do whatever you want to, you can be impactful, you can have that infusion of work and life where you're satisfied, or just something we haven't touched on at all? I'll give you the last minute.
I think, we just had a really, really great crop of summer interns come through. So I'm coming fresh off spending a week with a bunch of them working on a project. So they kind of come to mind. I kind of think of what would I tell them as they left us and they're going back into school and they're starting to have these discussions about what is my future and what do I need to look at. But I feel like, they need to find a place that challenges them. They need to think about what lifestyle they want to be living in, because you're going to have some companies that will, work you really, really hard, but you may want that. You may want to work the 60, 70 hours a week because you're getting paid for it, while you're, maybe single or without kids, and you have that flexibility. That might be exciting and fun for you, and that's okay. But it's also okay if that's not what you want. If you want the more work life balance. So I think it's okay to try things and go work for places, until you figure out what your optimal company is. And it's okay if that changes throughout your life. It's okay if what worked for you initially was great, but now you maybe want to try a different opportunity. It's okay to try things It's okay to get it wrong. It's okay to ask questions, and it's okay to make mistakes. What's important is to have managers and leadership that support you no matter what those mistakes are, and that you learn from them, and that we're always just really cognizant of why we're doing what we're doing. A lot of what we're doing is the silent thing in the background that, as long as it's going well, we'll never get acknowledged for, and that's what we want. Um, but it's most important to think like, I'm not just doing this math problem. I'm not just sizing this culvert. I'm making sure someone gets to work safely. I'm making sure that I'm not inhibiting the flow of commerce. It's kind of things you don't necessarily think about. But I would say, as a manager of people, it's most important for me to know your learning styles and your communication preferences, and just have a very open conversation about our pros and cons and weaknesses. I may really love something, I may really hate to do something, but as long as I'm honest, I know that work isn't always fun. Sometimes you have to do the thing you don't like to do, and just, you know, we're all people. Everybody makes mistakes. No one's above board with that. So just go into it with a positive attitude and try to make an impact, and try to be very open to the different people and the different experiences that those people you work with can bring to the table.
Absolutely. Well said. At the end of the day, be impactful. Keep your passion, keep your vision, be true to yourself. And yeah, some days you really hate having to do what you have to do, but you got to do it to get to the next thing, which is something you love to do. And that works for school, that works for work, that works even in life. As long as you're true to yourself and stay to the mission, then you're going to be successful, however you define it. And that's great. And you are. And I appreciate the time that you've volunteered and donated to this process. I appreciate your being willing to open up and be so candid about issues and activities in your life. As I said, there's things I could ask for the next hour that I'd be interested to find out. I'm sure the listeners would be interested in listening to as well. But that's about all the time we have. So hope to see you soon. You take care. Probably see you at the section meeting, maybe coming up in a few weeks. Good deal. And to those of you that tuned in, you take care, and we'll talk next time.
Thanks for listening to the latest episode of the Infrastructure Network.